We're on problem number 6 in set 2, and we have a rectangle. It says the following questions are about the rectangle shown here. So we have a rectangle, and let's just draw it up over here on our board so that, oh, I'm trying to get my drawing instrument. And let's just put this, actually I should put a little lower so I can put my information around it. Okay, so we're given a rectangle, and we're given also um, information regarding it. We see the length and the width. So this is the width is 3y, and the length is x. Okay, now we're given a series of questions or instructions. We read A, write an expression for its perimeter. Now, we understand that the perimeter is basically the sum of the sides, right? And that's how we did it before. So we could give the expression, we can start off with 3y plus x plus 3y plus x, right? Now, we could have also said, well, I know it's 2 times the length and 2 times the width, so I could have also said 2 times 3y plus 2 times x, right? And that's basically what we have here, but if we were to use our what I would consider probably be the better formula would be to do the multiplication because it is a rectangle. And if we did this, we can just simplify. Now we could have just added these two and would have gotten the same that we're going to get here, which is basically 2 times 3y, which is 6y plus 2x. So the answer to this would be, the expression for its perimeter would be 6y plus 2x. Now it says write an equation stating that its perimeter is equal to 30. So we know that this is the expression for its perimeter. Now we're going to specifically say that it needs to be 30. So this is the expression. And really, you need to learn these words, very important. And here we're going to give an equation, and we're simply going to say that 6y plus 2x, or it could be written 2x plus 6y. Typically we do like to write them in alphabetical order, so it might have been better to write it that way, but there's no harm the way it's written. And that's going to be equal to 30. So this would be the equation. And again, the equation is created by creating a relationship to a value, in this case the value of 30. If we were to look at the expression, there is no relationship to any value other than we know that we're dealing with a perimeter and that we can add the values of these of these sides to get the perimeter. But we're not stating particularly what the actual perimeter is. And in the second part, we are doing that, so we're equating it to the value of 30. Hence, we have an equation, and now we have limited values that we can actually use here for this particular equation. And we're given values here of x is equal to 3 and y is equal to 4. X is equal to 6, y is equal to 3, and x is equal to 1 and y is equal to 12. And we're asked, can these actually be? Can we do that? So you really need to plug in to see if it equals 30 when you plug in those values for x and y. And then lastly, we're asked to work with this from an angle of area. Okay, now area is different. Okay, let me just go ahead and erase this area here. Now we know area, we're dealing with multiplication, are we not? All right, so just erase. And let's look at this from a perspective of area. Now area, we know that we multiply the length times the width. Okay, so area is equal to length times width, whereas actually perimeter, and I could have written that down, is equal to 2 times the length plus 2 times the width. Okay, and that's what we did before. Now, if we were to take the area, we would have to multiply. Let's see, it would be area is equal to the length being x and the width being 3y. Now that's a little bit strange, but we would basically come up with the expression 3 times x times y. That would be 3xy. And now that's an expression again. And guess what? They're going to tell us to write an equation, and that this equation is equal to 36. Well, we say area is equal to 3xy, and they're saying the area is 36. So we would have to say 36 is equal to 3xy, or we can write it the other way around. 3xy is equal to 36, right? So we now have the equation part of this. Now the next question is, well, if x is 3 and y is 4, can this be the area? So we'd have to do the multiplication this time. Before we were doing some more, adding, multiplying and adding. In this case, we're just going to multiply. So we would say 3 times 3 is 9 times 4 is 36. So in the first case, h, it would be true. But would it be true for I and j? You'd have to multiply again. So in your examples, you'll have similar problems. All right, so we are now using these equations in two variables to determine area, to determine perimeter, and in some cases we don't have just one part of a puzzle. We have two parts to a puzzle. We have two variables, and we see that we can basically treat them the same way we were treating equations with one variable. It becomes very difficult to solve anything without having an answer to at least one of the variables. So you're generally going to be interjecting a value for one, either x or y. You can always leave an equation as is and say this is a true equation only, but of course it would only be true if those values x and y are values that would make it true. So we'll move on to number 7 in our next video.